So, to introduce today and to really kick off this first part of today where we'll be looking at, in a way, looking back, taking stock of what's been achieved over the last 10 years, I would like to welcome Martin Scheringer. He is a professor of environmental chemistry at the Masaryk University in Brno, Czech Republic, and a senior research scientist at ETH Zurich, and importantly, he is president of the board at the Food Packaging Forum Foundation. So please welcome Professor Dr. Martin Scheringer.
Where do I move the slides?
Over here.
Yep. Yeah, thank you, Jean-Paul, and good morning, everyone, and welcome to this event, our 10th workshop. I'm still overwhelmed by all that, how much has been accomplished, and that we really have reached this day. It's a special day for all of us, and as Jean-Paul said, we hope it will be interesting and productive for all of you. So yeah, my name is Martin Scheringer. I'm the president of the board of the Food Packaging Forum Foundation, and I want to show some highlights from these 10 years of work by the FPF team. Earlier this year, we celebrated the 10th anniversary of the FPF, and this is just an impression of the wonderful lunch we had with speeches and entertainment in one of the old guild houses here in Zurich. 10 years of FPF, 10 years of work. Of course, this cannot be summarized in 50 minutes now, and that's why I will just highlight some of the, I think, really big and lasting accomplishments, contributions of the FPF team that will change the landscape of and the way we see food contact materials and chemicals. This is one of the pages of the FPF website. So most of the outputs of the work of the FPF are available via the website. They have different formats. We can open here the menu of the resources tab, and you see they range from fact sheets to databases to research projects that are ongoing and going on for several years. Then there are dossiers that provide a lot of background information with a high level of resolution. Then there are also peer-reviewed papers the team publishes in the primary peer-reviewed scientific literature, and that's a very important element of the work. And then there are book chapters, fact bites. This is the page I just opened here. This is a new format that was introduced this year, where in a very concise, quick way you can find key information about essential aspects of food contact chemicals. And then there are also videos of many of the talks and presentations that have been given by the team over all 10 years, many of the 10 years. And there is a blog, Unwrapping Food Packaging, and there's also a page on coronavirus and packaging. These formats, and I invite all of you to really check out the website. It's rich, and these different formats of outputs have all also different, let's say, pace, timescales. There is a high pace of a daily news update. Then there is the newsletter released every 2 weeks. But then there are also kind of slower contributions, such as the dossiers that have been developed mostly by Birgit Goyeke, sitting here, as background information that's detailed and rich, and this is also meant to last for long. And then there's also databases, and I would like to highlight or to focus on 2 of these databases. At first glance, this may sound a bit strange because databases, that sounds technical and dry and even a bit boring. But I can assure you it's really the opposite. These databases provide so much new information. They change the way I think that we can see how we can see the landscape of food contact materials and chemicals. And that's why I would like to focus on these 2 databases, the Fccdb, the Food Contact Chemicals Database, and the FCC MyGex. So yeah, the first is the Food Contact Chemicals Database, FCCdb, and this is the result of a long time work and project led by, I'm just looking, Xenia Groh, who is not yet here, but will probably join us later today. Over years, Xenia and the team, supported by the team, have extracted the identity and also some properties of more than 12,000 chemicals that have been listed for intentional use in food packaging. They extracted them from, as you can see on the left, a wide range of 67 sources, information sources, be it industry inventories or databases or government lists of chemicals that have been officially registered for use in food contact materials. Then these chemicals were all listed in a large Excel sheet where we can find their identity, their name, their CUS number, and where they show up in any of these 67 information sources from different countries all over the world. And then in addition, and that's really very important here now, what was also collected was information about the hazards of these chemicals, the hazardous properties, such as the environmental hazard and human health hazard that are defined in the globally harmonized system for the classification and labeling of chemicals, or ETC properties, or properties as a PBT chemical, a persistent bioaccumulative and toxic chemical, or presence in important lists, such as the substances of very high concern list under REACH. That is additional information that's also available for each of these chemicals. And this hazard assessment or evaluation of the chemicals against these hazard criteria has shown that there are 608 chemicals for which there is a substantial hazard, and that means that these chemicals should prioritized for elimination from phase out from use in food contact materials. The database is available. You see that there's a page, the Fccdb page on the website of the FPF, and it has been described in a peer-reviewed publication led by Xenia Groh. And again, the Excel sheet is available for download. That's the first one that I would like to highlight here, because I think it's an enormously valuable resource for many kinds of investigations and projects. Then the second database is what we call the FCC MyGIGS database. And that's the outcome of a long-term project that has been led by Birgit Goike, sitting here. She has been for many years a scientific officer at the FPF, and she has led this huge effort here. This database is different. It is not just a list, and it was not possible to extract chemicals or information from other lists. This database had to be built from the beginning, from scratch, from small pieces of information that had to be collected in a very tedious and demanding way. What it offers is it shows information, or it lists chemicals, almost 3,000 chemicals, for which it has been proven or has been shown empirically in experiments that they move out of food contact materials, be it that they migrate into food or food stimulant, or that they can be extracted in extraction experiments from the food contact material. So this is really empirical information about chemicals that move out of the food contact material, where they would be supposed to stay. The way this was built was really dramatic, I would say, and adventurous, and not easy, because what the team did was they searched in the wide range of scientific databases for publications, individual scientific studies that would report measurements, experiments where these chemicals were measured and were found or not found to migrate. And the initial number of hits was more than 19,000. So imagine 19,000 records, and then in a painful process of slowing this down or narrowing this down by checking the titles, the abstracts, to see if these are really pertinent or not, the team then managed to narrow this down to a number of 1,210 core papers, scientific studies that really provide information about how chemicals migrate out of food contact materials. And then all the findings listed in these publications had to be extracted and arranged in a way that could then build the database. So that's the background, that's how this project worked. And the database is also available, but not just as a list that could be downloaded, but in a different format via a web tool, an online tool that was built by Lindsay Parkinson here in the back. She is the one who built that fantastic tool, where you can push on these panels and find the chemicals that have been identified, have been found, either in all food contact materials, that's on the left, that's the entire database, or a subset selected for a certain type of food contact material. This is plastics, because they are particularly important, or a subset of chemicals that are particularly important, namely PFAS. So if you do this and click on this, or open it up, then we see here on the left a list of the chemicals that have been found in these experiments. and the number of database entries per chemical. This is how often a certain result or a real result was reported for a certain chemical. There can be even several results in one paper. That's why there are more database entries than papers, than publications. And you see that the chemical that has the highest number of entries is DEHP. That's what we can read from here. And then you can go down and see all the chemicals and how often they have been mentioned in these publications. The second in the middle is where we can see database entries per food contact material. So that's what's also important, to break this down in a different way, not according to chemicals, but according to types of materials. So there's plastics, paper and board, metals, multi-materials, glass and ceramic, and other FCMs. So here you can see, if you are interested in a certain type of material, you can find out what chemicals have been identified. And of course, for all of this, you can also find the references to the studies that demonstrate what you have found and what you want to use, perhaps in your own work. And then at the bottom, you can also see more details of what the database provides. So was the chemical detected or not? Because in some cases, the chemical was investigated but not detected, which is good, because then it doesn't migrate, probably. And also what kind of experiment was performed, because the experiments are different, be it that chemical was found in real food, or a food stimulant was used to check if the chemical moves, or if an extraction experiment was performed where the chemical was then found in the extract from the food contact material. And on the right, also important, the type of materials. You see there's single use and repeated use. That is also an important point, that in many cases we find then that, for example, single-use plastic is an important element that shows up very often. Just as an example, if you enter here on the, you see this here, you can enter the name or the CAS number of a chemical. I did this here for bisphenol A. You can do this, then you see it just is reduced to just one chemical here. It's of course one chemical that is listed then found for the food contact materials. This is just bisphenol A, and you see then again all these how many database entries there are for bisphenol A in plastics and bisphenol A in the other food contact materials, and so on. So just to give a flavor of an idea of how this works, it's really simple. I tried it myself. I managed to find out what I wanted to find, and that's just to show you how well this works and how useful it is. So thank you, Lindsay, for all that fantastic work. Because it's so important not to just have all this, but also make it available and accessible. So the transfer of the knowledge is a key element of all the work, and that's why this is so important, so good to have this. Good. Again, this is described in a peer-reviewed publication, where you can find many of the details of how this was done. And as the last bit of what I want to show this morning is, if we now look at these two databases in comparison or in combination, what is the picture that we find? And it is interesting because, and as I said at the beginning, this is exciting and interesting. We can learn so much from these databases. The big circle is the 12,285 chemicals in the Fccdb. So the chemicals that are listed for intentional use in food contact materials. The small circle is the chemicals that were found to migrate. And they do overlap, but the overlap is, we thought, surprisingly small. Because then on the right, you see there are almost 2,000 chemicals that were found in these experiments to migrate, to leave the food contact material, but they were not on any of the lists that shows the chemicals that have been notified or authorized or listed for intentional use. So these are chemicals that may have been used without kind of permission, or chemicals that we can't really control. We'll see this in a minute. So that is really a surprising and interesting finding. So that is, we have here exactly, so that's either chemicals that nobody really wants to have in the food contact material. That's the so-called NIAs, the non-intentional added substances, but they are there and we can't get rid of them. That's one part of these substances that were found and reported. But others may be chemicals that were added intentionally but were not listed. So in a way that was kind of illegal, or what we would call that. And then on the other hand, there is a large number of chemicals that are in principle at least available and allowed to be used, but have never shown up in any of these studies that investigate migration of chemicals out of food contact materials. So perhaps they have never been used, but that's unlikely for that large number. So there is a lot of more chemicals. There are a lot more chemicals for which it would be important to perform experiments like this and find out how they behave in the food contact materials. Good. This is just to illustrate to you how this works and what we can learn from these databases. I find that fascinating. As I said, I think it really opens up a totally new perspective of a new view of the landscape. So to conclude, there are these two databases. They are available free of charge as all the work provided by the FPF. There is now a known universe of more than 14,000 FCCs, food contact chemicals, but there may be more. They have not been identified. There are still several hundreds of hazardous food contact chemicals that are still in use and should be prioritized for phase-out. And there are these almost 3,000 chemicals for which migration out of food contact materials has been demonstrated empirically. We can use the database to assign, the MyGex database to assign the food contact chemicals to food contact materials, to really break it down according to materials. That is very important, I think, and many more things. It is really an invitation for you to use the databases in your projects to explore what you would like to learn, what you would like to investigate. With that, I'm at the end here, and thank you very much for your attention.